Hey everybody, we're going to solve another trig equation here. We're looking for all the solutions on the interval from 0 to 2 pi, but we're going to use the trick that we learned at the beginning of this lesson to see if there are any solutions that would fit in this interval by picking from the list of all the solutions. So we're going to set up this problem. Here we notice that we're looking for when sine of x over 2 is negative root 3 over 2. I'm going to let theta equal x over 2 so that I can look at this a little bit more plainly. So sine of theta equals negative root 3 over 2 in the third and the fourth quadrant, because that's where the y coordinate is negative. So theta would equal, we're pi over 3 past pi, so that's 4 pi over 3. And theta would also equal 5 pi over 3, just pi over 3 short of 2 pi. Plus the 2n pi gives us all the solutions for theta. But we're not looking for theta, we're looking for x. So I'm going to make x over 2, I'm going to substitute back in x over 2, equal to 4 pi over 3 plus 2n pi, and I'm going to make x over 2 equal to 5 pi over 3 plus 2n pi. Now if I'm looking for x, I'm going to multiply both sides of this equation by 2. So that gives me x equals 8 pi over 3 plus 4n pi. And over here we have 10 pi over 3 plus 4n pi. All right, well, if I plug in 0 for n, if n equals 0, then x equals 8 pi over 3. This is already bigger than 2 pi, so it doesn't fit in the interval given. If I choose 0 over here, I get 10 pi over 3, which is definitely bigger than 2 pi. So neither of these work. So let's try n equals negative 1. So x is going to equal 8 pi over 3 minus 4 pi, which is 12 pi over 3. So that gives me negative 4 pi over 3. That's not between 0 and 2 pi. But maybe if I do it over here, it'll work. So I have 10 pi over 3 minus 12 pi over 3. That's negative 2 pi over 3, which is less than 0. So all of my solutions seem to be falling outside of this range, which makes sense. If this had been positive, then maybe I'd be able to fit one in there. But because I'm starting in the third and fourth quadrants here, and I'm doubling my period, then both of these fall outside of the range of 0 to 2 pi. Now, if I had started in the first and the second quadrant and I doubled my period, these might be somewhere where I could find a solution for it. But it turns out that there is no solution for this problem, which is fine. That's fine. There's no solution. Remember that you can play through these videos as many times as you want, and always email me if you have questions, if you're not sure of something. We're actually going to skip this one. We're not going to be dealing with decimals. I'll make sure that there aren't any problems like that on the exam, okay? But let's not skip this one. This is just good fun here. All right, so we are looking for all the solutions of this equation. All of them. It doesn't say between 0 and 2 pi. It says all of them. Find all of them. And I'm also looking at this and I'm saying, hey, this looks a lot if I let x equal sine theta, this is 2x squared minus 5x plus 2 equals 0. This is a quadratic. I can factor this to solve. So that's what I'm going to do first. I'm going to factor this. So 2x and x is the only way I'm going to get a 2x squared. And then the only way I can multiply two numbers to get a positive 2 is if one of them, with a negative in the middle, is if one of them's negative 2 and the other one's negative 1. And so I want negative 2 to be multiplied by the 2 over here to make me a negative 4 minus another 1x will give me the minus 5 that I have in the middle. So that means that x equals 1/2 and x equals 2. But remember, x is not x. X is sine theta. I'm actually looking for theta. So I'm looking for when sine theta equals 1/2, and I'm looking for when sine theta equals 2. When does sine theta equal 2? It doesn't ever equal 2. This is silly, right? There is no angle where sine of theta equals 2. 1 is the biggest number I can get out of sine, and negative 1's the smallest, so this is silly. Oldest joke in the book. All right, but where does sine theta equal 1/2? Well, that happens when theta is pi over 6, and it happens when theta is 5 pi over 6. Okay, well that works, but we want to find all the solutions. So we're going to add 2n pi here, we're going to add 2n pi, and we're going to say where n is an integer. There we go. So now we have all the solutions to this equation. All right, so we're gonna save the last two problems for the next video, and these next two problems are definitely more of a challenge. And I'm going to present them, and there's going to be problems kind of like that on the problem set, but the problem set you already have the answer key to, and I promise you that they won't be this difficult on the exam. I just like to show you where you can go with this, and if you can do these more difficult problems, then you'll have no problem with the easier ones on the exam. Okay, I'll see you in the next video.